In your last lesson, you learned how to measure line segments with geometric tools. Today we are jumping to Chapter 6, page 262, where you will learn how to determine the length of a line segment in a different way. Our objective for today is to learn to find the length of a line segment by finding the distance between the two endpoints. We will be working on the coordinate plane. Before we begin today's lesson, there are some things I want to review with you that you learned in algebra. In Chapter 1 of algebra, you learned about ordered pairs on a positive coordinate plane. Just as you use a number line to graph numbers, you used a coordinate plane to graph ordered pairs of numbers. A coordinate plane has a horizontal x-axis and a vertical y-axis that intersect at a point called the origin. The origin is labeled as O. Its coordinate pair has a value of 0, 0. In an ordered pair, the first number is the x-coordinate. The second number is the y-coordinate. The coordinates of the origin, like I said, are 0, 0. The ordered pair 4, 5 is shown here graphed at the right. In this example, point A is 5 units to the right of the origin and 2 units up. So the x-coordinate is 5, the y-coordinate is 2. The coordinates of the point A are written as 5, 2. Don't forget to put parentheses around your ordered pair. Point B is 0 units to the right or left of the origin and 4 units up. So the x-coordinate is 0, the y-coordinate is 4, and the coordinates of point B are 0, 4. Let's plot the points 1, 3 and 3, 0 in a coordinate plane. To plot point C, we begin at the origin and our x value says 1, so we move 1 unit to the right. Our y value is 3, so we're going to move 3 units up. To plot the point D at 3, 0, again, begin at the origin, move 3 units in the x direction, which is to the right, and then 0 units up. So D actually lies on the x-axis. In Chapter 4 of algebra, you went further with plotting points. In Chapter 1, you used a coordinate plane to graph ordered pairs whose coordinates were non-negative. If you extend the x-axis and the y-axis to include negative values, you divide the coordinate plane into 4 regions. We call them quadrants, and they're labeled from right to left, quadrant 1, quadrant 2, then we go down to quadrant 3, and back to the right is quadrant 4. Points in quadrant 1 have 2 positive coordinates. Points in the other 3 quadrants have at least 1 negative coordinate. For example, point P is in quadrant 4. It has an x-coordinate of 3 and a y-coordinate of -2. A point on an axis, such as point Q, is not considered to be in any of the 4 quadrants. It would just be on one of the axes. Let's try some. Can you tell me the coordinates of point A? Well, we look at point A. We see that it is 3 units to the left of the origin, 4 units up. So the x-coordinate is going to be -3. The y-coordinate, because we went up, is still just 4. The coordinates would be -3, 4. Point B, again, if we start at the origin, is 2 units to the right, which is our positive direction. But it's 3 units down, which is a negative direction. So the x-coordinate is +2, but the y-coordinate is -3. The coordinates of this point B are 2, -3. Now that we've reviewed working with points on a coordinate plane, let's get on with learning how to find the distance between 2 points. Distance on the coordinate plane. When 2 points lie on a horizontal line or a vertical line, it doesn't have to be the axes, the distance between the 2 points can be found by subtracting one of the coordinates. In the coordinate plane below, points A and B lie on a horizontal line. Points C and D lie on a vertical line. The distance between points A and B is -4 minus 1, or 5. The distance between the points C and D is -3 minus 1, or 4. This formula can be generalized to find the distance between any 2 points. Theorem 611 tells us the distance formula. If D is the measure of the distance between 2 points whose coordinates are x1, y1 and x2, y2, the distance will be the square root of x2 minus x1 squared plus y2 minus y1 squared. Let's look at this example. We're asked to use the distance formula to find the distance between J, which is -8,6, and K, which is the point 1, -3. We're asked to round to the nearest tenth if necessary. So we use the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. We're going to take the square root of that entire expression. Here what we're going to do is we're going to replace the x1, y1 in our formula with the value -8,6. We're going to replace x2, y2 in our formula with the value 1, -3. We are able to do that because of our substitution rule. If those are equivalent values, we're able to substitute them. We then combine 1 minus -8 and we get 9. We combine -3 minus 6 and we get -9. So now we have 9 squared plus -9 squared. And we just simply subtracted to come up with those two numbers. We're now going to square 9. 9 squared is 81. We're going to square -9, which is also 81. We're now going to add those two numbers together, and that gives us 162. Our final step is to take the square root of 162, and you can use your calculators to do this. The answer is going to be 12.7. So the distance between those 2 points is 12.7. Let's try it together. Let's find the distance between each pair of points. We're going to round to the nearest tenth if necessary. Let's start with the first set of points in example A. We have M is 0,3, N is 0,6. So again, we're going to use our distance formula. We're going to replace the point x1, y1 in our formula with our first point, 0, 3. We're going to replace the point x2, y2 in our formula with our second point, 0, 6. Now our problem looks like 0 minus 0 squared, and 0 minus 0 is obviously 0. We have 6 minus 3 squared. 6 minus 3 when we subtract gives us 3. So now we have 0 squared plus 3 squared. We're now going to square each of the numbers within the parentheses. 0 squared is 0. 3 squared is 9. We add those two numbers together. 0 plus 9 gives us 9. And again, final step is to take the square root of 9 and we get 3. Problem B. Let's use the distance formula and replace x1, y1 with -3, 4, x2, y2 with 5, -1. Again, we're going to replace by substitution. We're going to subtract within our parentheses. 5 minus negative 3 is going to give us 8. Remember, when we subtract a negative, we add those two numbers. 1 minus 4 gives us a negative 3. We're now going to do our squaring. 8 squared gives us 64. Negative 3 squared gives us 9. We'll add the two numbers together to get 73 and take the square root of 73 to come up with a distance of 8.5. In this problem, we see where using the distance formula is much more efficient than actually measuring with the distance with a tool. Lena takes the bus from Mills's Market to the candle shop. Mills's Market is 3 miles west and 2 miles north of Blunden Park. The candle shop is 2 miles east and 4 miles south of Blunden Park. How far is the candle shop from Mills's Market? Again, we would not want to get out with a measuring tool and have to come up with that distance. So we simply take our coordinates, plug them into the distance formula, subtract, square, add, and take the square root to come up with a distance of 7.8. The candle shop is about 7.8 miles from Mills's Market. Let's try one more together. Find the distance between the point 1, 2 and the point 3, 4. What's going to be our first step? You're right. We're going to write down our distance formula. Second step, substitute the given numbers into our formula. Third step, let's do some subtraction. 3 minus 1 gives us 2. 4 minus 2 also gives us 2. Let's square the numbers in our parentheses, and we get 4 and 4. We add those together to give us 8, and we take the square root of 8 to get 2.8. So the distance between these two numbers is 2.8. Here are more problems to practice with. Find the distance between each pair of points, round to the nearest tenth if necessary. Go ahead and pause the movie here. Perform the distance formula with these two numbers, and go ahead and play again when you're ready to check your answer. Did you get 2? Let's go on to the next one. Again, please try the problems on your own. Pause the movie until you're ready to check your answer, and then hit play again. Here we have the point 0, -1 and the point 0, -6. When you're ready, you'll find that the answer should have been 5. For the points 5 minus 0 and -1, 0, give it a try. Did you get 6? Let's try the points -3, 4 and 5, 4. Go ahead and do the work. The answer here should be 8. And we have a point y, 5, 6, and b, -5, -6. Go ahead and pause it, do the work. You should have gotten 15.6. Again, feel free to take the square roots on your calculator. Okay, I think you're ready to try it on your own. Tonight's practice work is from pages 265 to 266, problems 4 through 26 even.